Hi guys, and welcome back to the recurrent neural network session. Today we are kicking off this session for recurrent neural networks. This is one of the most advanced algorithms that exists in the world of supervised deep learning. So let's get started. In machine learning, we have something like supervised and unsupervised. When it comes to deep learning, we have a breakdown of supervised versus unsupervised deep learning branches, and here we have got artificial neural networks, which we have already talked about. We have already talked about convolutional neural networks as well, and today we are talking about recurrent neural networks. So this is just so that we see where we are in the big picture of things, slowly getting to the unsupervised part of the course. But nevertheless, let's focus on RNNs today. We talked about ANN, CNN, and now we are talking about RNN. If we could link those to some parts of the human brain, and if it all makes sense, then CNN is much easier. It's vision, recognition of images and objects and so on. So that's the occipital lobe, and today we are talking about RNNs. And as you will find out, RNNs are like short-term memory. They can remember things that just happened in the previous couple of observations and apply that knowledge going forward. So I'm giving away so much already. You pretty much know the rest of this tutorial, but nevertheless, so that's the frontal lobe. Now let's try to understand the intuition of recurrent neural network and the architecture of recurrent neural network, and we'll continue understanding the unrolling recurrent neural network, and also understand the problems or the disadvantages of using a recurrent neural network, such as exploding and vanishing gradient problem, and what is the solution for this. We'll discuss about the solutions also for the same, and also we discussed about the advanced RNN, one of the RNN's variant, the advanced LSTM. Also we are going to take a look at it, and finally we'll try to understand what is backpropagation through time. So what is RNN? A recurrent neural network, or a type of neural network where the output from previous step are fed as input to the current step. So what does RNN do? Well, okay, let me just come here. So this is, just look at this. This is a old school representation. Right, so what does this the RNN do? So, well, we squash it all together. They're all still there, but think of it as if we are looking from underneath this neural network. So we are looking in a new dimension. So it's still there, it's just flattened out. We are adding a new dimension to all of this, but remember that those neurons, the whole network is still there. Nothing changed. We just squashed it for our purposes. Then to simplify things, we are just going to change these multipliers into 2. Then we are going to twist whole thing, make it vertical, because that's a standard representation. Look here, this is the vertical thing, right? So, and then in terms of neural matrices, we are going to color them. Instead of green, we are going to color the hidden layer in blue, and there you go. So we are going to add this line. So this is the line, I added it here. And what does this line do? Well, that line is the temporal lobe, and this is an old school representation of RNNs, and basically means that this hidden layer not only gives an output but also feeds back into itself. So again, this is an old school representation. So the common kind of approach is now to unwind or unroll this temporal loop and represent ANNs in the following manner. This is how it represents. If you unroll this, we can say it like this. So you can see that again. Don't forget that we have lots of these things happening. So you are looking in a new dimension, that the layers are actually still there. So this line is the temporal lobe. This hidden layer not only gives an output but also feeds back into itself. The common kind of approach is to unroll this temporal lobe and represent like this.